Hi, my name is Ralf Donner. Welcome to Carr Challenge. One of the things that I'm very excited about with the Carr Challenge is its ability to break down barriers, to allow networking of potential quants across the world, and to effectively provide a forum for those who perhaps have an interest in finance but maybe do not live in one of the major financial centers or haven't had a particular financial academic background but who still are interested in this kind of thing and want a chance to compete in this world, to have an introduction to some of the most senior quants and professionals in this field, and just to further their careers. Now, although we have quants from all kinds of different backgrounds, I'd just like to talk a little bit about the connection between physics and finance, because that's specifically my situation. So one of the reasons that people from a physics background can be easily attracted into finance is because there are some of the very same concepts that are being applied in the two areas. So if you take, for example, traditional options pricing, well, everyone knows that the Black-Scholes equation underpins basic options pricing. Well, it turns out that this is a precise reformulation of the heat equation in physics. And so if you are used to numerical solutions of the heat equation, then automatically you also have a link to this world of finance. And it turns out that the payoff of an option diffuses through to provide you with the initial value in the same way as heat diffuses through a metal bar. And this is a fascinating connection in physics, one of very, very many. That means that it's an exciting prospect for people with a physics background. And in fact, the way that I got into finance in the first place is quite a funny story. What happened is that Morgan Stanley showed up with a bunch of equity derivatives quants one day at the Oxford Theoretical Physics department, and they said, do you like solving differential equations? And we said, yes, or at least we can do it. We're quite comfortable with it. And they said, well, why don't you just help us to do that? And so I found that I was surprised. I wasn't even aware that such interesting mathematical problems could apply in physics. I'll give you one example. Complex analysis. It's an area that you look at in mathematics and you think, what could possibly be the application of integrating in the complex plane outside physics? Well, it turns out that there is a famous model for options pricing that requires you to do precisely that, to construct a branch cut and to figure out how to do an integration in the complex plane for pricing an option. So it turns out that even these esoteric areas of mathematical research turn out to have applications in finance.